Now, section 11.3, we're learning to integrate things to do with trigonometry, okay? The way we're going to do that is we're going to think of them as though they are trig identities. Now, with a trig identity, you start with something that has some trig in it, and you rearrange that thing until you get the other side, right? So you start with the left-hand side, you simplify it till you get the right-hand side. Now, in this case, we're starting with an integral, and that integral is something to do with sine, cos, tan, sec, cosec, or cot, right? And it may be things squared, maybe things added together, all sorts of stuff. But what we need to do is we need to manipulate it into something that we can integrate. So this list here of integrals, let's have a look at it. These are the things that we can integrate. So we're aiming for one of these, okay? We're aiming to turn it into basically a sine, a cos, a sec squared, a sec tan, a cosec cot, or a cosec squared. Now you can perhaps see why it's really important that we have this list memorised. It's no good starting with, I don't know, something like sec x tan x squared. I'm picking one from example 7 here. It's no good starting with that and thinking, well, I need to turn that into something that I can integrate, but not having in your head the things that you can integrate. So when you get an integration question and there's some trigonometry involved, it might just be worth in the corner, in pencil perhaps, writing down what can we integrate. We can integrate sine, cos, sec squared, cosec squared, cosec, cot, or sec, tan. And when I've got an x here, it could be a linear function of x instead, okay? Like we did in section 11.3. So we start with our trig and we aim for one of these. Now we've seen that, well, the obvious thing to do here, look, would be when we expand the brackets, well, this one, great, that's on my list, I can integrate that bit. Sec tan, great, that's on my list, I can integrate that bit. Tan squared, that's the only bit that's going to cause us a problem, okay? But if you're working through the book in order, and we're looking at example 7, we've already seen example 5. And in example 5, we realise that actually, tan squared is in an identity, isn't it? 1 plus tan squared x equals sec squared x. So there is a link between tan squared and sec squared, and I can convert my tan squareds into sec squared, basically. Tan squared is sec squared minus 1. So that is the integral of sec squared x plus 2 sec x tan x plus sec squared x minus 1 with respect to x. Now this is something that we can integrate. We can integrate that and that and that and that. But it's really important that we have this list in our heads nice and fresh, because if we don't, we're going to get to this point and think, oh, we've still got a big mess of trig. What are we going to do with it? And the answer is, well, we're sorted here. This is now easy to integrate. This is just going to be tan. Sec tan integrates to sec. Sec squared integrates to tan. And minus 1 integrates to x. Don't forget your constant of integration. And there we go. Sorry about the small children playing in the background, by the way. I don't know if you can hear that on the video. Now, there is one more trick in this section. So, like I said, there's not much new information, but there's a few hints there. Basically, I'm saying take the trig, rearrange it into something you can integrate, and integrate. There is one trick, though, which will trip you up. By the time you get to the end of this chapter, you'll have loads of ways of integrating things, and you'll look at something like this, the integral of sine squared, and all sorts of things will pop into your head. Maybe I can use this, maybe I can use that. And actually there's a particular trick. So somewhere, please, in your revision notes, make a note. Sine squared and cos squared, there is a particular trick that if you don't learn it, you probably won't think of it. And that particular trick is this. Cos of 2x is cos squared minus sine squared. So cos of 2x, if you remember our identities, 1 minus 2 sine squared. And you can prove that by dividing through by cos squared here. Sorry, not divided by cos squared, but cos squared is 1 minus sine squared, isn't it? So you change the cos squared into 1 minus sine squared, we get this one. And if we change the sine squared into 1 minus cos squared, we get 2 cos squared x minus 1, okay? So it's these two that we're interested in. If we're trying to integrate sine squared, and let's just take this one, and I can say 2 sine squared x is exactly the same as 1 minus cos 2x. So sine squared x is a half minus a half cos 2x. Now, for an A-level exam, you might just want to have that memorised as an identity. If you're going to examine, it'll save you that couple of minutes just working it out. It's up to you, depends how much you like deriving things quickly and how much you like memorising formulae. So, the integral of sine squared is the same as the integral of 1/2 minus 1/2 cos 2x with respect to x. And that is 1/2 x minus 1/2. Cos integrates to sine. Yeah, cos does integrate to positive sine, doesn't it? Yeah. And then we've got to divide by the coefficient of x, which is a half. Don't forget to add your constant of integration. And then we can tidy up afterwards, all right? So if you've got sine squared or cos squared, the way you integrate them is you use the cos double angle formula. I'm sure you can do the same with cos squared for yourself, but you must make a note of that somewhere, because I promise you somewhere in an exercise it's going to crop up and a bunch of people are going to get stuck on it because they've forgotten that particular little trick. If you're unlucky, it'll come up on the exam. If you're lucky, it'll come up in the exam. A bunch of people have forgotten it and you will have revised it and remembered it because you've taken my advice and you've made a note and you've revised it very carefully. Integrate sine squared, use the cos double angle formula. Integrate cos squared, use the cos double angle formula. So far, integrate anything else to do with trigonometry, manipulate it until it looks like one of these things, and then you can integrate. Later on in the chapter, we'll have some other methods that might work, so things get complicated. But so far, up to 11.3, that's all we can do. So that's a good skill to practice. Good luck with 11.3, that's the lot.